Today I'm going to talk to you about the special systems of equations. And yes, systems of equations have specials also. As a reminder, a system of equations is just two or more equations with the same variables like you see right here. And the solution is where they meet on a graph, as you can see on this graph at 0.4, -3. Those are the only two numbers that will fit for x and y to make both of those equations true. But sometimes it doesn't work out the way we expected. So let's see what that means. I'm going to solve this system and I'm going to use substitution. So as a reminder, y equals 2x minus 4. So I'm going to put that where y is right here. So I'm going to do 6x minus 3 times 2x minus 4 equals 8. I'm going to go ahead and distribute that -3. And I've got a problem here because when I combine like terms right here, what happens when I do 6x minus 6x? It goes away. And I get a 12 equals 8. Do you remember this from equations when we were solving equations, when all of a sudden the letter disappeared? Well, when the two numbers don't equal each other, what was the answer? No solution. And that's the same thing here. This is no solution. And that will happen once in a while with a system. Let me show you what that looks like on a graph. Here are the two equations that we just put into substitution, and I've graphed them. And do you see what's happening? They're parallel lines. So they're never going to intersect. And if they don't intersect, then there's obviously no solution. I'm going to use these two equations to show you another special. First of all, I'm going to use elimination, and I'm going to multiply this times, I think, -2. And this one I'm just going to keep. So when I do that, that's going to be -8x plus 10y equals -14. And then I'm not changing this one, and it's 8x minus 10y equals 14. Are you seeing what I'm seeing here? When the x's cancel out, the y's cancel out, and even the 14s cancel out. And so I literally have 0 equals 0. Is that true? Does 0 equal 0? Absolutely, that's true. And so this, again, just like your equations, when the two sides are equal and the letters are gone, is infinitely many solutions. All right. So what I want to do is show you what that looks like on a graph. Here's what it looks like. And you might be thinking, you have just one line. And you're right, but I actually have two lines. They're just right on top of each other. Basically, if I were to simplify both these equations so that they were solved for y, you would see that they have the exact same slope, the exact same y-intercept. They are the exact same line. And so they have, where do they intersect? Everywhere. So they have infinitely many solutions. So if the two lines intersect in one spot, you have one solution. If the two lines are parallel and they'll never intersect, you have no solution. If the two lines are graphed right on top of each other, in other words, they are the same line, then you have infinitely many solutions. All right, there you go. Those are the 3 types of solutions you can get with a system of equations.